Objective geology, multiple choice questions with answers. This is the UPSC Combined Geoscientist 2020 question paper, solved question paper. This solved question paper is useful for various competitive exams like CSR, NET, GATE, GSI and other exams. Welcome to set 3. Coming to the first question. Influence of dissolved water is one of the process of magmatic differentiation, and it involves A. Alkalis and certain metals coordinate with the water and concentrate in the regions of lowest pressure and temperature. B. Alkalis and metals are hydrophobic, so they move from water saturated area to water deficient area. And C. Different chemical potential of water throughout the magma chamber. And D. Water provides a way to gravitational rising of heavy crystal. So influence of dissolved water is one of the process of magmatic differentiation, and it involves alkalis and certain metals. They coordinate with the water and concentrate in the regions of lowest pressure and temperature. Magmatic differentiation, it varies significantly based on various factors, and most notably the presence of water. So an abundance of volatiles within the magma chambers, it decreases the viscosity and it leads to the formation of minerals bearing halogens, including chlorides and hydroxide groups. So it involves alkali and certain metals. They coordinate with the water and they concentrate in the regions of lowest pressure and temperature. A is the correct option. Next question. During the complex process of reaction between magma and invaded rock, magma becomes modified by incorporation of material originally present in the wall rock. And this process is termed as magmatic A. Differentiation, magmatic mixing, magmatic assimilation, magmatic crystallization. So the correct option is, so here assimilation. So what is assimilation? Assimilation, if crustal rocks are picked up and incorporated into the magma and dissolved to become the part of the magma, and they say that the crustal rocks, they have been assimilated by the magma, and this process is known as a magmatic assimilation. C is the correct option. Next question. Kimberlites are alkalic rocks, characteristically ultramafic in composition. They differ from lamprophytes and lamproids in. So how do the kimberlites they differ from lamproids? So the choices are A. Kimberlites have high silica, and B. The contents of alkalis, that is sodium oxide and potassium oxide, and B. The contents of magnesium oxides are low in kimberlites, and B and D. The contents of alkalis are high in kimberlites. The correct option is the contents of alkalis, that is sodium oxide and potassium oxide. Kimberlite is composed of at least 35% of olivine together with other minerals such as mica, serpentine and calcite. The kimberlites, they differ from lamprophytes and lamproids in contents of alkalis, that is sodium oxide and potassium oxide. So B is the correct option. Next question. Crystallization may be localized at a cooling margin where the temperature is lower than the central parts of the magma. Thus, A solid phase is formed, B. A liquid phase is formed, C. A solid and liquid phases are formed, and D. A liquid and gaseous phase is formed. So, crystallization may be localized at margins where the cooling is faster and the temperature is lower than the central part, and by the action of the diffusion, the minerals they are formed during the early crystallization, they may be concentrated towards the margin of an igneous body, and a solid and liquid phases are formed. C is the correct option. Next question. A certain mineralogical change in rock that is also of local extent but is of different character from either contact or cataclastic metamorphism is called A. Cataclastic metamorphism, and B. Hydrothermal metamorphism, C. Dynamothermal metamorphism, D. Regional burial metamorphism. Hydrothermal metamorphism is the result of interaction of the rock with a high temperature fluid of variable or different composition, and the difference in the composition between an existing rock and the invading fluid, it triggers a set of metamorphic and metasomatic reactions. So here the correct option is B. Hydrothermal metamorphism. Next question. Nucleation in metamorphic rocks is A. Faster when entropy change is smallest, and B. Faster when entropy change is highest, and C. Initiated by entropy but not depends on entropy in advanced stage, and D. Controlling factor for second order transitions. So nucleation in metamorphic rocks It is nothing but it is faster when entropy change is smallest, and nucleation is the term referring to the sequence of interlinked physical and chemical changes that together result in the formation of a new particle or nucleus capable of subsequent growth to form a crystal, and it increases or it faster when entropy, that means order of the disturbance, changes is smallest. A is the correct option. Next question. Consider the following regarding phase rule. A. Like F is the number of independent degrees of freedom for the system, C is the number of chemical components, and P is the number of phases. And the phase rule is expressed by which one of the following equations? A. F is equal to C plus P minus 2, and B. F is equal to C plus P minus 2, and C. F is equal to C plus P plus 2, and D. F is equal to C minus P plus 2. So the phase rule is expressed by the phase rule states that F is equal to C minus P plus 2. So thus for a one component system with one phase, the number of degrees of freedom is 2, and at any temperature and pressure within the limits can be attained. So according to the phase rule is expressed by F is equal to C minus P plus 2. D is the correct option. Next question. A foliation may be marked by the parallel orientation of the tabular minerals in a metamorphic rock with a sufficiently coarser grain size is called A. Cleavage, B. Schistosity, C. Gneiss-osity, D. Solution cleavage. That means a foliation when it is marked by parallel orientation of the tabular minerals in a metamorphic rock with which are sufficiently coarse grain in size is called as a schistosity. Schistosity is nothing but a mode of foliation that occurs in certain metamorphic rocks as a consequence of parallel alignment of platy and lattice-shaped mineral constituents, and it reflects a considerable intensity of the metamorphism. That means the changes resulting from high temperatures, pressures, and deformation. So B, schistosity is the correct option. Next question. Pseudotachylite are A. Thin seams of glassy igneous intrusion by extreme from the magma with mafic composition, and B. Thin seams of glassy rock produced of the results of the melting due to frictional heating and are restricted to dry rocks. C. Rock mass with a random fabric of interlacking with a tough texture and strength, and D. Fine-grained rock produced in the zone of intense ductile deformation, whereas the pre-existing grains have been crystallized as finer grains. So pseudotachylite is another dense cohesive rock that is composed of a dark glass or microcrystals, and it occurs as veins and often contains fragments of the host rock as the result of the localized melting of wall rock by frictional heating, which is caused by fast fault sliding. So it includes thin seams of the glassy rock which are produced due to melting, which occurs due to frictional heating, and these are restricted only to dry rocks. B is the correct option. Next question. When an igneous rock is metamorphosed and the original texture it continues to occur in the metamorphosed ones, the resulting texture is said to be A. Granoblastic texture, B. Blastoporphyritic texture, C. Porphyroblastic texture, and D. Xenoblastic texture. So blastoporphyritic texture is nothing but when larger grains or crystals that are surrounded by the fine grain matrix or glassy groundmass, and they are more common in extrusive igneous rocks but may also occur in medium to coarse grained igneous rocks. So when an igneous rock is metamorphosed and the original texture continues to occur in the metamorphosed one, the resulting texture is said to be blastoporphyritic texture. B is the correct option. Next question. Metamorphic facies can be defined as A. A range of chemical reaction under the process of metamorphism where bulk composition of altered rock remains same as the parent rock, and B. A range of pressure temperature conditions over which a particular common mineral assemblage or range of mineral assemblages are stable, and C. A physically separable constituents of the system in the form of a solid, liquid or gas, and D. A changing condition of the pressure and temperature which lead to reaction and production of new assemblage. So metamorphic facies are named for the rocks that form under specific conditions. Suppose if we say eclogite facies, amphibolite facies, etc. But those names did not mean that the facies is limited to that one rock type, but it can be defined as a range of pressure temperature conditions over which a particular mineral assemblage or a particular ranges of mineral assemblages are stable. B is the correct option. Next question. A specific change in mineral assemblage reflecting a metamorphic reaction and satisfying the condition of reaction equilibrium is called A. Isograd, B. Isopatch, C. Isocontour, D. Line of phase change. So the correct option is isograd. A line on a map connecting the points on the earth where the metamorphism of rocks occurred under same temperature and pressure conditions is known as an isograd. And these lines are established on the basis of distribution of index minerals, and these are useful in reconstructing the tectonic history of a given region. So this like a specific change in mineral assemblage reflecting the metamorphic reaction and satisfying the condition of reaction equilibrium is known as an isograd. A is the correct option. Next question. Scans. What are scans? Scans are A. Metasedimentary rock that are rich in calcium or calcium magnesium silicate. B. Recrystallized rock where all the igneous minerals recrystallized into high-grade metamorphic minerals. And C. Metamorphic rocks formed by hydrothermal alteration of limestone into marble. And D. A variety of calc silicate rocks formed by metasomatic interaction. So scans are variety of calc silicate rocks formed by metasomatic interaction between marble and the silicate rock. So scans or tactites. These are known as a coarse grained metamorphic rocks that form by the replacement of carbonate bearing rocks during regional or contact metamorphism and metasomatism. And scans, they may form by metamorphic recrystallization of impure carbonate protoliths and by metasomatic reaction of different lithologies, and they infiltration into the metasomatism by magmatic hydrothermal fluids. So scans are nothing but a variety of calcium silicate rock which is formed by metasomatic interaction between a marble, that is a calcium carbonate rock, and a silicate rock. D is the correct answer. Next question. In a baric type paid metamorphic belt, A. The high and low pressure belt of the same age occurred next to one another, separated by major faults. B. Two high pressure belts of the different age occurred next to one another. And C. The high and low pressure belt of the different age occurred next to one another, which are separated by faults. And D. Two low pressure belts of the different age occurred next to one another. In a baric type paid metamorphic belt, the high and low pressure belt of the same age, they occur next to one another, which are separated by major faults. A is the correct option. Next question. The steps involved in a metamorphic reaction will be the slowest in a natural geological setting and will therefore control the rate of the overall reaction is known as A. Rate limiting step, B. Surface step, C. Heat energy step, and D. Natural reaction step. So the step involved in a metamorphic reaction that will be the slowest during a natural geological heating and therefore it controls the rate of overall reaction. This is also known as a rate limiting step. A is the correct answer. Next question. The difference between carbonate and siliciclastic sediment is, so what's the difference between carbonate and siliciclastic sediment? A. The carbonate sequence occur in shallow tropical environments while the siliciclastic occurs worldwide at all the depths. And B. The carbonate sequence occur at deep marine environments while the siliciclastic occur at all the depths. And C. Both carbonate and siliciclastic occur at the same depositional environment with only difference of grain size and texture. D. The carbonate deposits result from shallow water bodies from interaction of current and waves, while siliciclastic sediments are the result of only deep calm water deposit. So siliciclastic, commonly referred as a clastic rocks, these are composed of terrigenous materials and these are formed by weathering of pre-existing rocks, whereas the carbonate rocks are composed principally of sediment which is formed from seawater by organic activity. And the carbonate sequence occur in shallow tropical environments while siliciclastic it occurs worldwide at all the depths. So the correct option is the carbonate sequence which occur in shallow tropical environments, whereas the siliciclastic it occurs worldwide and at all the depths. A is the correct option. Next question. Grain size interpretation in siliciclastic rocks is much simpler than carbonate and evaporites because A. Diagenesis in carbonates and evaporites obscures original grain relationship. B. Siliciclastic rocks are cemented on sea floor and easy for stratigraphic correlation. And C. For carbonate and evaporites, climate is no constraints. Sediment occur worldwide at all the depths. And D, in carbonate sediment, periodic exposure of sediment during deposition, it leaves deposits which are relatively unaffected. So the correct option is diagenesis in carbonates and evaporites occurs obscures original grains relationship. So grain size interpretation in siliciclastic rock is much simpler than carbonate and evaporites, because diagenesis in carbonates and evaporites, it obscures the original grain size relationship. A is the correct option. Next question. Hard grounds are A. Microscopic erosional surface on the underside of bedding plane formed by natural casts of erosional feature. B. Vortex erosion typically at the base of turbidity current. C. Originally bored surfaces which encrusted with fossils in growth position. And D. Resisted surface altered by erosional impact of large objects entrained in the flow. So hard grounds are stratigraphic horizons that are cemented syndepositionally, or they are near the seafloor. They are recorded from periods as old as the earliest Paleoproterozoic, but they are commonly they are known from the Phanerozoic belt. So hard grounds are organically bored surfaces which encrusted with fossils in growth position. C is the correct option. Next question. In sedimentary rocks, the beds that contain internal layers that are essentially parallel to the bounding bedding surfaces are said to be A. Cross stratified, B. Planar stratified, C. Composite bed sets, and D. Laminated bedding. So in sedimentary rocks, the beds that contain the internal layers which are essentially parallel to the bounding bedding surfaces are known as planar stratified. B is the correct option. Next question. Ichnofacies dominated by deep vertical burrows in a tidal zone named A. Scolithos, that is known as a scolithos, B. Crugiana, C. Zoophycus, and D. Nereids. So ichnofacies, it is dominated by deep vertical burrows in a tidal zone. It is named as a Scolithos. Scolithos means trace fossil assemblages. They exhibit low ichno-diversity. It is dominated by vertical dwelling burrows with reinforced wall lining, which is attributable to Scolithos or ichnofacies. So A is the correct option. Hope you have followed these questions, and thank you for your time. Hope you can explore geosciences, and see you in the next video.